In a good experiment, there should be an independent variable. That's the one that's varied by the person performing the experiment. And there should also be one or more dependent variables which respond to changes that are made in the independent. All other factors should be kept as constant as possible. This way, any cause-effect relationship between the independent and dependent variables can be more clearly identified. A confounding variable would be some factor that could potentially influence the dependent and make it impossible to discern the true cause of the observed changes that we see in the dependent variables. In each of the following, do you believe one of the variables would depend on the other? In other words, would a change in one variable cause a change in the other? If it's difficult to tell which variable depends on the other, would there be just an association between the two variables? You also may find that you think there's no association at all. For the first one, does exercise intensity depend on a person's heart rate? Or does the heart rate depend on the exercise intensity? So in my case, it's not like I'm going to go exercise because my heart rate is high. It doesn't quite work that way. It's actually the other way around. If I decide to do exercise, then my heart rate responds and it goes up. That makes heart rate the dependent variable. And exercise intensity would be the independent variable. So if we were going to make an experiment out of this, we'd want the experimenter to decide how much exercise each person does. And then they could measure the heart rate. Try the rest, and then I'll give my answers. When it comes to test scores and time spent studying, notice that it was sort of general. It didn't say which test we were talking about. If we were talking about the first test for a math course, then the time that people had spent studying for it could be considered an independent variable, and then their final score on the test would depend on how much time they spent studying. That's a possibility. But since the particular test wasn't described, is it possible that students who did poorly on a first test may decide to put more time into studying afterwards? So it could go both ways. The test scores could influence the time spent studying, and the time spent studying could influence the test scores. For that reason, I'm just going to say that there's an association between them. They have some kind of relationship with each other, but I can't really tell which one is the independent and dependent without more information. How about this one? Being given a placebo, which is a fake pill of no nutritional value, and symptom improvement. So it can be shown that if people believe they're being treated for something, then that could cause them to have improved symptoms. That means whether they get the placebo or not would be the thing that's decided by the experimenter. That's the independent variable. And then their improvement would depend on whether they had the placebo or not. It's a psychological phenomenon that's well documented. And that's why in most medical studies where people are being given medication, we want to actually give the control group a placebo. When it comes to weight and foot problems, it could be argued that a higher weight could cause foot problems. But it is also possible that if a person had foot problems, then that would lead them to potentially exercise less, and that could lead to higher weight. For that reason, I'll say there's an association between these. If you enjoy a sport, that could cause you to practice more. But if you practice more, you might get better at the particular sport and start to enjoy it more. I'm going to put association here. The next one says withholding affection from a subject and the subject's reaction. Does one of these things depend on the other? Yeah, this would be a classic type of psychological lab type of experiment. The researchers can decide how much affection to give, and then the reaction depends on the affection that they had gotten. In a good study, efforts must be made to limit bias as much as possible. This means that in surveys, we'd want to word questions so they don't lead the subject in a way where the wording affects the responses. And an example of controlling the effect that outside factors play in an experiment would be giving a control group a placebo, which is the harmless unmedicated treatment made to look just like the real treatment. Okay, what I've drawn here is an example of a single-blind experiment. In a single-blind experiment for a medication, for example, one group would be given a treatment and the other group would get the placebo. The group that gets the treatment is the experimental group, or treatment group. The other group will be the control group. Now, the reason why it's a single-blind experiment is that the people taking part in the study have blindfolds on. And that's just an analogy. But what it means is that they don't know whether they're getting the real medication or just the placebo. Could you think of a reason why the experimenter doesn't want the patients to know whether they're receiving the treatment or not? So the experimenter wants to be sure that both the control group and the experimental group equally experience placebo effect if there is one. That's because those who are being treated may improve for psychological reasons alone. We want to see what part of their improvement is actually due to the medication. That's a single-blind experiment. Notice that the researcher here doesn't have a blindfold on. What that signifies is that the researcher knows which people are in the treatment group and which people are in the control group. But in a double-blind experiment, even the researchers don't know who's receiving the treatment until the end of the study. Can you think of any reasons why the researchers should not know who's receiving the treatment? So an answer to that is, the researchers may subconsciously or consciously treat the subjects differently, and that may affect the outcome of the experiment. And this can often happen if the researchers have a stake in the outcome of the experiment, and it could happen if they want the experiment to go one way or another, even subconsciously. So they may treat the people differently without even knowing it. So there are 3 keys to a good experiment. Control is the process of isolating independent and dependent variables from outside influences. Control is compromised by confounding variables. Confounding variables occur when the experimenter can't tell the difference between effects of different factors on a variable. Randomization is the process of randomly assigning subjects to different treatment groups. An experiment may use a matched pairs design, where subjects are paired up according to similarity, and then one of them would be chosen to receive the treatment, and then the other wouldn't. People can be paired because of factors such as age, location, or some other physical or mental characteristic. Some of the best studies involve identical twins, where the people are so similar genetically that we can reduce the possibility of many confounding variables. Replication is the repetition of an experiment under the same or similar conditions. In science, results of experiments need to be reproducible in order to be considered valid.